Hello, hello, testing. Testing, testing. Oh, we gotta add audio. Audio capture device. And let's see, HyperX. Okay, testing, testing, hello. Huh. Let's see what's going on. Oh, that's right. Here we go. What's going on? Oh, that's right. Here we go. What's going on? Oh, that's right. Here we go. What's going on? All right, we have double audio there. Gonna mute the desktop audio. Testing. That is really good latency. 1, 2, 3, 1, 2, 3. That's like 3-4 second delay. That's awesome. All right. So what I want to get into today is some of the latest news that I've been compiling. Let me just bring up a list of the links here that I'd like to share. And then I'll go ahead and add, let's see, where's that at? Here we go. Okay, so let me scroll up. There's so much. There's like an educational series I'd like to do on various topics related to AI and how to develop, work with, and build local AI models. However, there's also kind of like a social aspect related to how that may affect our daily lives. There's also a natural healing segment I'd like to get into. But let's see. Let me just close this down. The live stream will be available after. Let's see. Ooh, it just got quiet. It's weird. Okay, I'm gonna close that. Yeah, I don't really have any show notes here. I was just kind of getting the streaming down. Okay. It's weird, like no matter what, I have that like white splotch. There's gotta be maybe like bring down my saturation a little bit. I'm gonna reset it to the defaults. Yeah, because like when I hold my hand out here, yeah, that's more of a natural tone. Then I pull back and then I got that like white glare. So what if we remove the contrast? That's just weird. I mean, that's kind of cool looking, but let's go back to defaults. Excuse me. Wow. Okay, defaults not working. There we go. that's actually better. Okay, we're gonna leave it like that. Do a motion JPEG mode. Okay. Rock the nation. Rock the nation. Now it's way too dark. It's like I can't win. All right, let's go back. Now we're gonna pump this back up. All right, I like this a little bit better here. I have a little bit of light. All right, how's that? What's our delay look like? Delay. Now we're up to 10 seconds. One. About 6 seconds. So it fluctuates. Rock the nation. Testing. What just happened here? need this open. Yeah, I don't even need that open. We're still live, right? Okay, so you can see here this device. This is a drone with 1, 2, 3, 4, 5, 6 propellers. But something unique here that you see is what looks like this like stream of sparks and fire flying out of one side. And this is actually not a propellant, so this is not being used to like propel the drone forward. This is actually a payload being delivered into the atmosphere. So they're burning some type of chemical mixture and extruding this particulate matter out into the atmosphere at specific altitudes and locations. And as you can see, there's multiple drones in this picture. There actually, in reality, could be dozens, if not hundreds of these. And what this is doing is actually seeding the atmosphere to produce or augment the weather to produce an increased amount of precipitation. So as you can see right here, it says make it rain. The name of the company is Rainmaker. They position themselves as a pro-human company. And they cite some statistics from California's Department of Water Resource. So they use rapidly deployable drones and new chemicals. I don't know what new chemicals are exactly, or if they're safe, how long they've been tested for, if we even want these chemicals in our air, because if you think about it, these chemicals are being used because of the size of the particulates. The smaller the size of the particulate, almost at a nanoscale, allows it to mimic the dust particles that form rain droplets within a cloud. And so then typically these rain droplets will fall down to earth still containing the chemical that they were seeded upon. So whatever these new chemicals are then raining down and falling into our water supply, but also our soil, where our vegetation, our produce, our trees, our grass, and yeah, once again into our water supply, our watershed. Existing cloud seeding chemicals are only viable in specific atmospheric conditions. Ours are tailored to be most effective in specific geographies. So it sounds like it's some kind of proprietary chemical mixture. And yeah, here is so you can see this technology is being used in planes and drones. So when people get called conspiracy theorists for talking about chemtrails. Well, I mean, what else would you call it? This is a chemical trail left by a plane, and now utilizing drones as well. So, whereas planes can only fly in certain types of weather and certain altitudes, drones can probably fly in and out of the clouds during any type of conditions because it's less of a liability if you lose a drone, and they're more agile in terms of their maneuverability. Custom developed drones to service hard to reach places. They operate in severe weather and remote environments, easily recharged, resupplied on site with minimal footprint. Cloud seeding benefits. So, the pro is it helps agriculture. Again, we don't know what those chemicals are and how they may or may not affect agriculture. Terraforming, turning deserts green. Hurricane mitigation. Can break hurricanes before they reach shore, but that's in a defensive outlook. What about in an offensive outlook? What if your desire, whether you're a government entity or a adversary, is to create or strengthen a hurricane? Would this technology, if it's capable of mitigating, is it capable of enhancing or creating a hurricane? And the same with hail. That would be such a catastrophic weapon if you can control and direct the flow of hail, which can stop commerce, and it could injure people, even kill people if the hail is large enough. So let's see, this company is on X. They're located in El Segundo, California. Oops. Let's see here. What is at this location? G-Ride, E-Ride, okay. Creepy van. Hydroflex, that looks creepy. So just some conspicuous. Yeah, I don't exactly see this Rainmaker company. You would think they had like a larger footprint of a factory or a nicer campus. I don't see them listed on the map here. Let's check out their Twitter. So they don't seem to even have an official Twitter. They just have this guy. Wait, doesn't that... That's a creepy logo. Like, what even is that? Some kind of angel of death? This guy looks like some kind of creepy activist. Is that him? Holding the chemicals in his hand. Got a damaged hand. Has like a double Jesus shirt. I don't even know what this means. Talks about Russia, Genghis Khan, some kind of plundering. People from California will record a tornado exactly the same way that they video a fight in front of a Jack-in-the-Box. Okay. Looks like he's part of the E-acceleration crowd. Future. Excuse me. So it's just their website, makerain.com. At a Rainmaker. Let's see. What if we type that in? Trying to click this work with us. Doesn't seem to go anywhere. I guess there's a form to talk to them. So this is a very ambiguous, seems like just a one-page website with very little information. So, but it seems like there's no legal ramifications for seeding random chemicals into our atmosphere. I don't know if there's any legal oversight. But you can see it right here. I mean, I was hoping for at least some more substantive documents or some kind of details about their process. There's a phone number here. I guess we could call them. What's on LinkedIn? Rainmaker Technology Corporation, Climate Tech, Los Angeles. Let's see, the people. This guy, Harry Thomas. This guy looks familiar. Jackson Yip. Atmospheric scientist. We're going to connect with this guy. Chemical engineer, University of Utah. Undergrad, San Jose. This guy we're going to connect with also. Hydrosat. I don't know what Hydrosat is. We'll take a look at that. Let's see, business development. Co-founder, co-president of the University Space Initiative at Georgetown. Intern at NASA with the chief economist. Director of Accounts Payable at Georgetown. Alright, what's Hydrostat? Information services. Okay. Hardware. That's a funny haircut. No offense, dude. Look at this picture. It's just raining down different chemicals. So he's been there 3 months. This guy has been there 6 months. This guy's been there 9 months, so this sounds like a relatively new company. What? Let's see. 2 to 10 employees. They were founded last year. Alright, we're going to put a pin in this. So this guy's been there 1 year, CEO, makes sense. He's one of the founders. Oh, excuse me. Yeah, but just to bring this back to what initially sparked my interest here, let me bring up this video that was published by PBS Nova on YouTube. Okay. Okay, so now this video was published 10 months ago. And let me see if I can pull up the audio here. I'm going to mute myself.
Save the drought-stricken West by bringing more rain and snow to the region. That's what these engineers think. They've parked the trailer up here in the mountains of Colorado in hopes of changing the weather. And there's dozens of them just like this in use right now.
Okay, so I've paused the video right here, so now you can see the apparatus that they're using. They park these at high elevations, and there's this kind of this pipe that goes up with this box, and it's got this like torch that keeps burning. So similar technology to what we saw in the Rainmaker drone. See right here? So if we go back, there's some type of chemical that's contained within the box, and it's feeding into this torch. And the goal is that when this chemical is burned, it releases these very, very tiny particulates into the atmosphere. And so they've actually done tests that by releasing these particles into the atmosphere in key places and at key times, I'll play the video, they are able to increase the precipitation and pattern of rain clouds. And they say that their result in doing this is only increasing it by like a factor of 2%. But I'll fast forward later on into the video where they show a different method where they're actually using either a helicopter or an airplane that can release these chemicals in a zigzag pattern, and then they can check the radar and see a rain in that zigzag pattern.
It might all sound like science fiction, but it's a weather modification technique called cloud seeding, and it was first done successfully as early as the 1940s. In Colorado, some ski towns were cloud seeding as far back as the 70s, and it's also been used around the globe. China's cloud seeding program reportedly had a plan to make clouds rain before they had a chance to float over the Beijing Olympic Stadium. You can find cloud seeding from California to North Dakota. But how does cloud seeding work? To learn more, I've come to Colorado to see how seeding works up close and personal. The night before I arrived, the clouds above me were seeded.
We are approaching the location of our cloud seeding generator.
Scott Griebling is a water resources engineer for the local Water Conservancy District. The locations chosen for these sites have the right elevation and can reach the perfect clouds.
Our district has come to the conclusion that cloud seeding and weather modification is a very safe and very cost-effective way of increasing local water supplies.
So how do you seed a cloud?
Hey, welcome to our remote generator.
Garrett Kamens is president of a cloud seeding company that operates hundreds of cloud seeding sites.
I just wanted to clarify that that is not Moby. That was not Moby that we saw walk out of that trailer. Although he does kind of look like Moby, that's not Moby.
Of a cloud seeding company that operates hundreds of cloud seeding sites.
And it sounds like you're terraforming or completely changing the climate of an area, but that's not.
All right, so I just wanted to show you that he did use that term, terraforming. And we just heard that term terraforming used right here. So what did they say in their business plan? Cloud seeding benefits is terraforming. Okay, so I don't know, maybe they've had some advancements since the data in this video was released 10 months ago. But I mean, this company was started about a year ago, so I mean, I don't know, maybe they're just trying to downplay their tactics. I'll continue.
Since clouds are basically water vapor, the idea is to release particles into the clouds that will attract water, making it easier for water droplets or snowflakes to form. They get heavier and eventually fall to Earth instead of staying in the sky. This Colorado team uses a solution with a chemical called silver iodide, which, when burned, splits into billions of particles per gram.
Ice is the perfect seeder. Clouds seed themselves with ice crystals. Silver iodide is really the closest and similar structure as ice, so that's why we're using silver iodide.
Here, Kamens activates the flame. It contains a silver iodide solution mixed with propane.
Silver iodide. Sorry, I just paused it because I would like to get that lady's name. We're going to follow her on Twitter and see what she's up to. So I'm going to pause it real quick. WTF Reach. Friedrich. Thought I was on Twitter here. Excuse me. This might be her. Looks like she doesn't have any posts, so forget about it. Yeah, that did look like her. That and that, yeah, very similar. Just missing the glasses. KFCUB. Colorado University Boulder, CUB. This is probably like CU of B. Alright, anyway.
Using silver iodide.
Here, Cammons activates the flame. It contains a silver iodide solution mixed with propane. A series of tanks and regulators manage the pressure and exact flow rate of the silver iodide solution.
A typical storm system will only drop about 10% of its moisture. We're hoping that the storm system will drop 10.5 to 11.5% of its moisture.
Okay, but does cloud seeding actually work?
We would come out with research aircraft and with ground-based radars, and we would basically measure the atmosphere prior to cloud seeding and during cloud seeding.
The landmark Snowy project set out to discover just that. It took a pretty clever approach. A plane flying back and forth dropped chemicals into the clouds. When the team studied the resulting precipitation, they found it had snowed in a zigzag pattern, matching the path of the seeding agent's flow.
Okay, so they just mentioned the landmark Snowy program. Just gonna see if we can pull anything. So, looks like, yeah, so Snowy, advancing the science of cloud seeding, that looks like the same thing. This was from 2018. Orographic clouds. What is that? So mountain clouds. Okay. Comprehensive suite of instrumentation, ground-based radars, airborne sensors. I mean, I'm just wondering, I know that radar can be affected by particulate matter other than rain clouds, such as like a chaff grenade can be used to jam radar, and it gives off the same appearance as rain, but I suppose they know what they're doing here. Hopefully the particulates that they're using don't offset the radiological equipment. So this is all done on the premise of the need for water in arid regions around the world. Oops. What happened there? Okay. So it looks like, yeah, so this is the type of aircraft that's being employed. And yeah, maybe that's the device that's releasing the particulate. Yeah. So if we view this full size, yeah, so this looks like I don't know what this is, some kind of the wing mounted flare rack. Okay. Instruments mounted under the wing, so it looks like they're utilizing both of these. Interesting. So I guess like one flare goes off after another in the time sequence. Yeah, very interesting. Or you have a controlled release of pressured particulate. I mean, yeah, it's just, you label something like chemtrail, oh, conspiracy, fringe, and then no more discussion on the topic. It's fake news. But if you know the right terminology, WMI seeding aircraft, okay, now all of a sudden it's science. And that's all I'm getting at. I mean, it's not like we have the power to stop it or endorse it. It's just like when we see this occurring, like, how do we know, okay, now that this was successful in 2018, is there additional funding for further research? Is this now going into phase 2 and 3? Is this now becoming a commercially viable technology that's being employed? And if so, what regions is it being employed in? How often? Are there any potential side effects? I mean, right here we see the benefits, but you know, every procedure has to have at least some types of cons, drawbacks, side effects, blowback, something. So, you know, it would be fair to be able to at least have this more open in the mainstream so that other scientists at universities could research the potential pitfalls or ways to ensure that this is safe, necessary, effective, reliable. And then also, if there needs to be some type of regulation as to what locations it can be done, whether it's residential or keep this restricted from like agricultural land, either way, you know, if this is just one random article, I mean, I suppose I could type this into Google Scholar and see what we get. Get to Scholar, interesting. No, I'm good. Alright, so if we do by, excuse me, date. So, there we go, look at this. Physical properties of background aerosols. Okay, so I think this was the first one. Giant cloud condensation nuclei based cloud seeding, which uses 1 to 10 nanometer size hygroscopic powder, has been known to be an effective warm cloud seeding material, especially compared to flares. Okay, so we saw a picture of those flares in the previous article. In a rain enhancement weather modification operation, this is because it's able to produce 3 times the number of condensation nuclei compared to that from flare-based seeding. The resulting nuclei would then accelerate collision and coalescence process within the clouds, which then result in higher precipitation events. However, the challenge in utilizing this material is its tendency to coagulate in room temperature and high humidity environment. Let's see. There are not many literatures that discuss degradation behavior of this type of seeding material. So, and again, so what is this? This is NaCl. Is that the same chemical? Sodium chloride? Okay. With cabosyl anti-caking agent. I don't know what cabosyl is. We could look that up. hydrophilic fumed silica. Interesting. And then NaC, sodium chloride, I'm assuming is not dangerous. Water softener, soda ash. Could harm aquatic plants and animals, disrupting their osmoregulation. Let's see. Salinization of fresh water and increasing metal leaching. Okay. So look at this. 70% of this salt is retained in a local watershed. That's not good. So you're salting your fresh water. Okay, fine, whatever. Anyway, let's see. All right, so that is from February, like a couple days ago. Let's check that other article. During the seeding in National Orographic Wintertime Clouds, the Idaho experiment were frequently observed in very high resolution. The study examines multiple flight segments. Irregular crystals. Excuse me. So it looks like they're conducting this in Japan as well. So that's just the first 3 articles from the past 2 weeks. Looks like this science is alive and well. All right, well, I mean, it's kind of getting a little boring, but just wanted to check the current research that's out there. So you could just set up an alert, which I probably will, and just catch the latest articles related to cloud seeding. So I'll go ahead and create an alert, and yeah, we'll go from there. Keep you updated. All right, that's all for now, folks. Thanks for tuning in.